An operator is a symbol or words that are used in performing different kinds of operations in Python. When I say operations, I'm talking about things like adding two numbers together, comparing two values, performing multiplication, and so on. These are operations. So an operator is a symbol or words that are used in performing operations. On the other hand, an expression is a combination of values and operators that evaluate into a value. When I have 5 plus 5, this is a typical example of an expression. Here we have a value, we'll have an operator, and we'll have a value. And together, this expression evaluates into a single value, which is 10. 5 plus 5 is equal to 10. Now, I can assign this expression to a variable. I can have total is equal to 5 plus 5. What happens is that 5 plus 5 is going to evaluate into 10, which is subsequently assigned to this name. Now I can have print total, and this is going to display 10. In expressions, you can have as many values and operators as possible. I can have plus 3, minus 2, but ultimately, expression evaluates into a single value. And because of this variable declaration, this expression is going to evaluate into a value, which subsequently will be assigned to this name. Now let's run it again. And this time around, we have 11. Now, we're going to be looking at the different types of operators that we have in Python. So we have the arithmetic operators, which are used for arithmetic operations. We'll have the comparison operator, otherwise known as relational operators. We'll have the logical operators, the membership operators, the identity operators, and finally, we'll have the bitwise operators. We're going to be starting with the arithmetic operators. These are operators that we use for arithmetic operations. Here we have addition. We'll have subtraction, multiplication. Now, under division, we have two types of division. We have what we call the true division, and we have the integer division. Now we have exponentiation and the modulo operators. Now let's start with the addition. Here we have addition, and to perform addition we use the plus operator. So here I'm going to have total is equal to, and I'm going to be adding two numbers. So let's say we have 1 and then the plus sign followed by the next value. Now, if I print out the total, it is going to give me the sum of 1 and 3. So let's try this out. And from our terminal, we have 4. Now I can include more values. I can decide to have plus 5, plus 10. So in essence, we're trying to add these values together. And if we run the program, we're going to get 19. So if you want to perform addition, you use the plus symbol. Now let's look at the next operator, which is subtraction. And to perform this operation, we use the minus sign. So in this case, I'm going to have a variable called result is equal to, I'm going to be providing the first value. So here I can have 10, then a minus sign, and I'm going to provide 5. So let's try this out, and we have print result. Here we're going to have 5, which is 10 minus 5. Now let's look at the next operator, which is multiplication. So we have multiplication. To perform this operation, we use asterisk. So here we have result is equal to 10 multiplied by 2. So this is the operator we use for multiplication. We don't use x. If you want to perform multiplication, you use asterisk. Now let me print it out. Here I'm going to have print results. And of course, we're expecting 10 times 2, which is 20. Now, if we run the program, you can see that we have 20. Now, let's look at division. And like I said before, we have two types of divisions. We have the true division and we have the integer division. So when I say division, I'm talking about true division. Here we have result is equal to, let me have 10. To perform division, you use the forward slash. So this is the symbol we use for division. So after the 10, I'm going to have a forward slash and I'll provide the next value. So we have 2. In essence, we're trying to divide 10 by 2. Now let's run the program. Here we have print result. Then we'll run the program and we have 5.0. Whenever you perform a true division, you are going to get a float. If we divide 10 by 2, we're expected to have 5. But because we're performing a true division, it is going to give us a float result. So instead of having 5, because we're performing a true division, it is going to include a decimal part. Now let me change this to 3 and we'll run the program. And here we have 3.33335. So this is how we perform division. Now let's look at the next one, which is the integer division. And for this operation, we use double forward slash. Now let's try out something. Here I have result is equal to 10 divided by 2. Now let's print out the results. And here we have 5. Now let me change this to 3. And here we have 3 and then run the program again. Now you can see that we have 3. What happens when you perform an integer division is that it is going to perform the division, but it is going to remove the decimal part. In essence, we're expected to have 3.3333 because 10 is not perfectly divisible by 3. But when you perform an integer division, it is going to perform the division and then strip off the decimal part, which makes the division incorrect. So if you want to perform division in the true sense of it, you use the true division. But if you are simply interested in getting the integer part after the division, you use the integer division. Now let's look at the next operator, which is the exponentiation. Exponentiation is something as raised to power. And for this operation, we use double asterisk. So here we can have result is equal to 2 raised to power 3. What this means is 2 times 2 times 2. Now let me run the program. And here we have print result. 2 times 2 times 2 is equal to 8. And if we run the program, you can see that we have 8. Now I can change this to 3 raised to power 3, which is 3 times 3 times 3, which will give us 27. So if we run the program this time around, we have 27. Now finally, let's look at the modulo operator. The modulo operator, we use the percentage symbol. So when we say modulo, we're talking about remainder. Now, take a look at this example. I have result is equal to 5. Then I provide the modulo operator and 2. Now, let's print out the results. And if we run this program, we're going to get 1. So what happens here is that if you divide 5 by 2, you are going to get 2 remainder 1. That remainder is called the modulo. And this is the reason why we have 1 as the result. If I change this to 3, this is going to give us 5 divided by 3 is going to give us 1 remainder 2. That remainder is the modulo. So if I run this program, I'm going to be getting a 2. So let's run it. And as you can see, we have 2. So these are basically the operators that we use in performing arithmetic operations. We use the plus symbol for addition, the minus sign for subtraction. We use asterisk for multiplication. And for division, we have 2 types, the true and the integer division. For the true division, we use the single forward slash. For the integer division, we use double forward slash. Now we have exponentiation. Exponentiation, we used double asterisk. And finally, we have the modulo operator. And for this operation, we use the percentage symbol. Now let's look at the comparison operators. Comparison operators, also known as relational operators, are used to compare 2 or more values. We'll have the greater than, the less than, we'll have greater than or equal to, less than or equal to, we'll have the equality and the not equality operators. Now let's start with the greater than. Here we have greater than. And for this operator, we use the greater than symbol. So we can have something like result is equal to 5 greater than 1. So this is a typical comparison operation. You are trying to compare this value and this value. In other words, you are certain that 5 is greater than 1. What this means is that if 5 is indeed greater than 1, we're going to get a true. If not, we'll get false. So let's run the program. Here we have print result. And if I run it, you can see we have true. And the reason for this is because 5 is greater than 1. If I change this to 4, we're also going to get true because 5 is greater than 4. But if I change this to 7, of course, 5 is not greater than 7, so we're going to get a false. So if I run, you can see that we have a false. Likewise, if I change this to 5, I'm trying to say that 5 is greater than 5, which is not correct. So if we run this program, we're going to get a false. So if you want to compare 2 values to determine whether a value is greater than the other, you use the greater than operator. Now let's look at the next operator. We have less than. And for this operator, we use the less than symbol. Now let me have result is equal to 4 less than 3. Of course, 4 is not less than 3. So when we try to print out results, we're going to get a false. So let's try it out. We have print result and run the program. And as you can see, we have a false. But if I change this to 2, 2 is indeed less than 3. So this statement is actually correct. So if we run this program, we're going to be getting a true. Now let's look at the next operation, which is greater than or equal to. And for this operation, we use greater than an equality symbol. So this is the symbol we use to perform greater than or equal to operation. Now I'm going to have result is equal to 5 greater than or equal to 4. Now let me print out the result. And if I run this program, we're going to get a true. So look at what happens. When you perform this type of operation, you are trying to check whether 5 is greater than 4 or 5 is equal to 4. In this case, 5 is greater than 4, and for this reason, we have our result to be equal to true. Now, if I change this to 5, look at what happens. First, we're going to check whether 5 is greater than 5, which is false. Now, we're going to check if 5 is equal to 5, which is true. And as such, result becomes equal to true. So if we run this program, you can see that we have true. Now, if I change this to 6 and run this program, we're going to get a false. So first, 5 greater than 6, which is not true. 5 equal to 6, which is not true. And as such, we have results equal to false. So this is for the greater than or equal to. Now, let's look at the less than or equal to. So here we're going to have results equal to 1 less than or equal to 3. Now let's print out the result. So just like the greater than or equal to, you are trying to check if 1 is less than 3 or 1 is equal to 3. And in this case, we're going to be getting a true because 1 is less than 3. So if I run it, you can see that we'll have a true. If I change this to 3, we're also going to be getting true because 3 is equal to 3. Now, if we run it, you can see we also have true. But if I change this to 4, 4 is not less than 3 and 4 is not equal to 3. And as such, we're going to be getting false. Now let's look at the next operator, which is the equality operation or equality operator. And for this operation, we use double equality. So whenever we perform an equality operation, we're trying to check whether two values are equivalent or whether two values are equal to each other. Now here I have result is equal to, and here I'm going to have 5 equal to 5. Then I'm going to print the result. Now pay attention to this. When you are using a single equality operator, you are performing assignment. For instance, I'm trying to assign this variable to the result of this expression. So when you use one equality operator, you are performing assignment. But when you use two equality operators, you are performing comparison. You are trying to compare these two values for equality. And because 5 is equal to 5, I'm going to be getting true. So if I run it, you can see that we have true. But if I change this to 4, I'm trying to assert that 5 is equal to 4, which is not true. And as such, we're going to be getting a false. Now, finally, let's look at the not equality operator. And for this operator, we use the exclamation symbol followed by the equality symbol. Just like the equality operator, the not equality operator checks whether two values are not equal to each other. So you are trying to establish whether two values are not equal to each other. So I can have result is equal to 4 not equal to 5. Now let's print out the result. From our expression here, we have 4 not equal to 5, which is correct. So if we run this program, we're going to be getting a true. But if I change this to 5, I'm trying to say that 5 is not equal to 5, which of course is not correct. So if I run this program, I'm going to be getting false. Logical operators are used to combine 2 or more Boolean values, or 2 or more expressions that evaluate to Boolean values. Under the logical operators, we'll have the logical AND operator, we'll have the OR operator, and we have the NOT operator. Now let's start with the AND operator. So here we have the AND operator. And like I said before, logical operators are used to combine 2 or more Boolean values, or 2 or more expressions that evaluate to Boolean values. Here I can have result is equal to true and true. So here we have a Boolean value. This is also a Boolean value. And we have the AND operator. If you are using the AND operator, the both values or operands have to be true in order for the expression to evaluate to true. In other words, this has to be true and this has to be true before the expression will evaluate to true. Now let me print out the result. So here I have print result. And if I run this program, we're going to get true. Now I can as well have true and true and true. This will also evaluate to true. So if you're using the AND operator, you need all the values to be true in order for the expression to evaluate to true. Now if I change this to false, I'm also going to be getting a false. So here we have false. Now let me remove this and change this to false and run the program. We're going to be getting a false. If I change it to false and false, we're going to be getting a false as well. So if we run this program, you can see we have a false. The only way we can get through is if all the values are true. So let me change this to true and as well change this to true. Then if we run this program, we're going to get true. Now let's look at the OR operator. So here we have OR operator. And for this, we're going to have result is equal to true or true. Now let me print out the result. So here we have print result. If I run this program, I'm going to get a true. If you are using the OR operator, you require at least one of the values to be true in order for the expression to evaluate to true. So if I change this to false, I'm going to be getting a true. So here we have true. But if I change this to false, it means that all the values are false. And as such, I'm going to be getting a false. For the expression to be true, you need at least one of the values to be true. If I change this to false or true, we're going to be getting a true. Now let's look at the NOT operator. So here we have the NOT operator. The NOT operator is basically used to negate a Boolean value. It is more or less like not true means false and not false means true. So I can have something like result is equal to true. Then before this true, I can write not. What this means is that I'm simply negating this value. So not true means false. Now let me print out the result. So here we have print result. If I run this program, we're going to get a false. Now if I change this to false, Not false means true. So if we run this program, we're going to be getting a true. So this is how the not operator works. Now let's provide a more realistic example. And like I said before, logical operators are used to combine two or more Boolean expressions or Boolean values. So we can have something like result is equal to. Here I'm going to be providing an expression that evaluates to a Boolean value. So I can have something like 4 greater than 1. Then I'll provide the AND operator. So here we'll have our AND operator. Then I'm going to provide another expression. And here I can have 5 less than 6. Now let's print out the result. So here we can have print result. If I run this program, we're going to be getting a true. Now look at what happened. 4 greater than 1 is going to evaluate to true. And 5 less than 6 is going to evaluate to true. So this is more or less like true and true, which will evaluate into a true. So this is how it came about with true. Now, if I change this to 4 less than 1, if I run this program, I'm going to be getting a false. And the reason for this is because this expression is going to evaluate to false. So this is more or less like saying false and true. So when you have false and true, the expression is going to evaluate to false. Now, I can change this to or. When you have false or true, the expression is going to evaluate to true. So false or true evaluates to true. If we run this program, we're going to get a true. Now let me change it back to AND. If I run the program, of course, it's going to show us false. Now, I'm going to be negating this expression using the not operator. So I'm going to be wrapping it inside of a parenthesis. So we'll have the closing parenthesis. Then I'm going to provide a not operator. So what happens is that this expression is going to evaluate to false. But because of this not operator, we're going to transform this false into true. In other words, we're going to have true and true. So here we have true and true. If we run the program this time around, we're going to be getting a true. So this is basically how we use the logical operators in Python. The next set of operators we're going to be learning are the membership and identity operators. So we're going to be starting with the membership operators. So here we have membership operators. And under the membership operators, we have the in operator and we have the not in operator. Membership operators are used to establish whether a value is inside a collection or sequence of values. For instance, in Python, there is what we call a list, which is a sequence of values. To create a list, we enclose values inside of a square bracket separated by commas. We can have something like nums is equal to square bracket. Inside of this square bracket, I'm going to provide the values. So we'll have 1, 2, 3, 4, and 5. Now, with the membership operators, I can establish whether a given value is inside of this list or inside of this sequence of numbers. For instance, if I want to establish whether 2 is inside of this list, I can make use of the in operator. I can have something like result is equal to 2 in nums. In other words, I'm trying to establish whether the value 2 is inside of the list. If the value is inside the list, it is going to return true. If not, it is going to return false. Now let me print out the result. Here I have print result. Now let me run the program, and as you can see, we have a true. If I change this to 1, I'm also going to get true because 1 is inside of the list. If I change this to 5, I'm also going to be getting a true. But if I provide a number that is not inside of this list, I'm going to get false. If I change this to 6, I'm going to get a false because 6 is not inside of this list. Now the next operator is the not in operator. This is the opposite of the in operator. In other words, I'm trying to establish that this particular value is not inside of this list. So I can have 6 not in. So here I have not in norms. And because 6 is not inside of the norms, this expression is going to evaluate to true. Now, if I run this program, you can see that we have true. But if I provide a value that's inside of this list, I'm going to get a false. So if I have something like 4 not in norms, this is going to return a false. So as you can see, we have a false. Now let's look at the identity operators. So here we have identity operators. Identity operators are used to check whether two values are exactly the same thing. Under the identity operators, we have the is operator and we'll have the is not operator. Now let me provide an example. Here I'm going to have norms, or let's say norms1 is equal to, I'm going to be making use of a list. So here we have 1, 2, 3. Here I'm also going to have norms2 is equal to norms1. Now let me have another variable. So here I can say norms3 is equal to, I can have 1, 2, and 3. Now I'm going to be using the is operator to establish whether any of these variables are the same thing. Because when we say identity operators, we're not trying to establish equality. We're trying to assert, or we're trying to establish that the two values are the same thing in memory. So if I have something like result is equal to norms1 is norms2. Now let me print out the results and run the program. This is going to be returning a true. And the reason for this is because norms2 is assigned to norms1, which means that they're exactly the same thing. When we get to deep copy and shallow copy, you understand more about the identity operators. But for now, I want you to know that when you are using the identity operators, you are not trying to establish whether they're equivalent to each other. You are simply trying to establish that these two values are the same thing or not the same thing. Now, if I change this one to norms3, then run the program, you can see that we'll have a false, in as much as they contain the same values, but they are not the same thing in memory. Now, if I write norms1 is not norms3, then this is going to be returning a true. So this is basically how to use the membership and the identity operators. As we dive deeper in Python, we're going to learn more about the membership operators and identity operators and how you can make use of these operators in your programs. Bitwise operators are used to perform operations on data at a binary level. Under the bitwise operators, we have the bitwise AND operator. And for this operator, we use the ampersand symbol. We'll have the bitwise OR operator. And for this operator, we use the pipe symbol. We'll have the bitwise OR. For this, we use the caret symbol. We have the bitwise left shift. Here we use the double less than symbol. And for the right shift, we use the double greater than symbol. So this is a symbol we use for the right shift. And for the bitwise NOT operator, we use the tilde symbol. Now let's start with the bitwise AND operator. Here we have bitwise AND. And of course, we use the ampersand for the symbol. Now take a look at this example. Here I'm going to have num1 is equal to 5 and num2 is equal to 6. I'm going to be performing a bitwise AND operation between num1 and num2. And for this, I'm going to have result is equal to num1. Then I'll provide the bitwise AND operator. So this is for the operator. Then I'm going to provide num2. Now let's print out the result. So here we have print result. Now if I run this program, we're going to get 4. Now you may be wondering, how did we arrive at 4? And like I said before, bitwise operations happen at the binary level. So first, we're going to be determining the binary equivalence of these two numbers. And to do this, we're going to be using the bin function. So here I can have print. Inside of the print function, I'm going to provide bin. And inside of the bin function, I'm going to provide num1. I'm going to do the same for num2. So here we can have print bin, then num2. If I run this program, this is the binary equivalence for num1, and this is the binary equivalence for num2. Now let's determine the binary equivalence for the result. So here we can have print bin, then we'll provide the result. Now, if I run the program, this is the binary equivalence for the result. Now, if you look at these binary values, you can say we have 0B. The B here denotes binary. So this is what happened behind the scene. For num1, we have 101. And for num2, we have 110. Now, I want you to imagine a logical AND operation between two Boolean values. The only way you can get it through is if all the operands or all the values are true. Now, I want you to see 1 as true and 0 as false. If you perform a logical AND operation between true and true, you are going to get a true. If you perform between true and false, you are going to get a false. In bitwise operations, operations happen bit by bit. At this level, we have 1, which is like true. And at this level, we have 0, which is like false. So when you have true and false, you are going to be getting a false. So when you have 1 and 0, 1 and 0 is going to give us 0. So here we're going to have 0. At this point, we have 0 and we have 1. 0 and 1 is going to give us 0. Then finally, at this level, we have 1 and 1, which is like true and true, and this will give us 1. And this is how we arrived at 100, which is equivalent to 4. Now, Let me change this to 7. If I run this program, we have 5. And 5 is equivalent to 101 in the binary. So first, we changed num2 to 7, and the binary equivalence of 7 is equal to 111. So I'm going to be changing this to 111. So I'm going to change this to 1. At this level, we have 1. At this level, we have 1. So here we're going to have a 1. At this level, we have 0 and 1. 0 and 1 is going to give us 0. Then at this level, we have 1 and 1. 1 and 1 gives us a 1. And this is how we arrived at 101, which is equivalent to 5. Now let's take a look at the bitwise OR operator. So I'm going to change this to OR. And for the operator, we use the pipe symbol. Now I'm going to change this to the pipe symbol. If I run this program, we're going to be getting 7. Now look at what happened. 5 is equivalent to 101 and 7 is equivalent to 111. If you're performing a bitwise OR operation, I want you to imagine performing a logical OR operation between two Boolean values. If you have true or false, you are going to get a true. If you have true or true, you are going to get a true. The only way you can get a false is if both operands are false. So if you have false and false, you are going to be getting a false. At this level, we have 1, which is like true. At this level, we have 1, which is like true. So 1 or 1 is going to give us 1. Here we have 0, and here we have 1. So this is more or less like false or true. So false or true is going to give us true. So we're going to change this to 1. Then finally, we have 1 or 1, which will give us 1. And this is how we arrived at 111, which is equivalent to 7. Now let's look at the bitwise XOR operator. For the bitwise XOR operator, we use the caret symbol. So I'm going to change this to the caret symbol. If I run this program, we're going to be getting a 2. Now this is what happens when you perform a bitwise XOR operation. In order for you to get a true, both values have to be of opposing values. In other words, you need false or true in order for you to get a true. If both values are the same, you're going to get a false. If you have false and false, you're going to get a false. If you have true and true, you're going to get a false. If you have false and true, you are going to get a true. If you have true and false, you are going to get a true. So the both values have to be of opposing values. So here we have 1 and 1, which are the same. And as such, we're going to have 0. Here we have opposing values. We'll have 0 at this point. We'll have 1 at this point, which will give us a 1. Then here we have 1 and 1, and as such, we're going to have a 0. So this is how we arrived at 10, and 10 is equivalent to 2. So this is how we arrived at 2 using the bitwise XOR operator. Now let's look at the bitwise left shift. And for this operator, we use the double less than symbol. So this is the symbol for the bitwise left shift. Now here I'm going to have num1 is equal to 4. Now I'm going to have result is equal to num1. Then I'm going to provide the bitwise left shift operator. So this is the operator. Then I'm going to be providing how many shifts I want to perform. So let me put 2. Now let me print out the result. So here we have print result. If I run this program, we have 16. Now let's explain what happens in the background. First, I'm going to be determining the binary equivalence of 4. So here we'll have print. Inside of the print function, I'm going to have bin, then num1. I'm also going to be printing out the binary equivalence of the result. So here I'm going to have print bin result. Then I'm going to run the program. So the binary equivalence for 4 is 100. Then the binary equivalence for the result, which is 16, is equal to 10,000. If you are performing a bitwise left shift operation, I want you to imagine something like this. The binary equivalence of 4 is equal to 100. So let us have 100. I want you to imagine that we have a lot of spaces around 100. So to perform a shift by 2, what this means is that you are going to shift the digit 2 times towards the left and adding 2 zeros at the right. So this is how we arrived at 10,000. Now let me change this to 3 and run the program. So we're going to shift it towards the left 3 times, which is 1, 2, and 3. And we're going to add 3 zeros in the front. So this is how we arrived at 100,000. If I change this to 1, so this is our original value. We're going to shift to the left once, and we're going to add 1 zero in the front. Now, if we run this program, we're going to get 1,000, which is equivalent to 8. So this is how we perform the bitwise left shift. Now let's look at the bitwise right shift. So here we have bitwise right shift. And for the operator, we use a double greater than symbol. So this is the operator. Here I'm going to change this operator to the bitwise right shift. Now let's run the program. If I run this program, we're going to arrive at 2. So look at what happens when you perform the bitwise right shift. Because we're performing a bitwise right shift, I'm going to be shifting these values once towards the right. Then I'm going to remove 1 zero from the right. So I'll remove 1 zero. And this is how we arrived at 10, which is equivalent to 2. Now, if I change this to 2, originally we have 100. I'm going to shift to the right 2 times. Then I'm going to remove 2 zeros from the right. And this will give us 1. If I run this program, you can see we have 1. So this is how we arrived at 1. Then finally, let's look at the bitwise not operator. And for this operator, we'll use the tilde symbol. I will not be going in depth in this operator because it has a lot of mathematical undertone. But for now, let's look at this example. Here we have result is equal to, I'm going to be providing the bitwise not operator. Then I'll provide a value. Now let me print out the result. So here we have print result. If I run this program, it is going to give us minus 11. If I change this to 5 and run the program, it is going to give us minus 6. So this is basically how we perform bitwise operations in Python. We have the bitwise AND operator, or have the bitwise OR, the bitwise XOR, or have the bitwise left shift, the bitwise right shift, and finally we have the bitwise NOT operator. Now let's look at operator precedence. When we're talking about operator precedence, we're talking about the order in which operators are evaluated inside expressions. So let's take a look at this expression. Here we have result is equal to 5 plus 4 multiplied by 3. Now let me print out the result. So here I can have print result. If I run this program, we're going to be getting 17. Now let's look at the expression. Here we have 5 plus 4, which will give us 9. And 9 times 3 is equal to 27. But if you look at our output, we have 17. The reason for this is because of what we call the operator precedence, that is the order in which operators are evaluated. So what really happened is that multiplication took place before the addition. In other words, this operation was executed before the addition. 4 times 3 will give us 12, and 12 plus 5 will give us 17. And this is how we came about with the value 17. In Python, we have what we call the paired mass, which is paired mass like this. The P stands for parentheses, the E stands for exponentiation, the D stands for division, M stands for multiplication, then addition and subtraction. Whenever you have an expression, Python follows this order in evaluating the expression. Now let's look at the example one more time. We have result is equal to 5 plus 4 multiplied by 3. Now, if you look at this rule, we have paired mass. What this means is that parentheses evaluates first, followed by exponentiation, followed by division and multiplication, and finally we have the addition and subtraction. Now, if you look at this expression, we have a multiplication. What this means is that this expression or this operation is going to evaluate first before the addition. So 4 times 3 will give us 12, and 12 plus 5 will give us 17. Now, assuming I wanted to perform this addition before the multiplication, I'm going to be wrapping 5 plus 4 inside of a parenthesis. So I can have something like this. And because we're following the paired mass rule, which means that expressions inside of parentheses are evaluated first, Python is going to first evaluate this operation before the multiplication. Now we're going to have 5 plus 4, which is equal to 9. Then 9 times 3 will give us 27. Now let me print out the result. So here we have print result. Now, if I run this program, we're going to be getting 27. Now, let's look at another example. So here we're going to have result is equal to 2 multiplied by 3 raised to power 2. Now, let me print out the result. So here we have print result. If I run this program, I'm going to be getting 18. And if you look at this expression starting from the left, you may get a different outcome, because from the left, we have 2 times 3, which is equal to 6. And 6 raised to the power 2 is equal to 36. But in line with the paired mass rule, exponentiation evaluates first, which means this expression is going to evaluate first before the multiplication. 3 raised to the power 2 is equal to 9. Then if you multiply 9 by 2, you get 18. And this is how we came about with 18. Now, assuming you wanted to perform the multiplication before the exponentiation, you simply wrap the multiplication inside of the parentheses. So here I'm going to have my parentheses. What this means is that this expression is going to evaluate first before the exponentiation. Now, we're going to be arriving at 2 times 3, which is equal to 6. 6 raised to power 2 is equal to 36. Now, if we run the program, we're going to be getting 36. Whenever you want to write an expression containing multiple operators, the PEDMAS rule should be a guide directing you on how to write the expression in order for you to get the expected outcome.